Thank you. So after this presentation is challenging. So, okay. The outline will be a little introduction. However, over the course of this day, we have more information. So I will talk about the electric ceramics for satellite applications and other factors affecting the properties of the material. So to get in context, and I will show some experimental results, a little conclusion and perspective in a sense. Okay, good. So developing ceramics materials for satellite applications will require low density, high quality factors, as already mentioned, Basel, and in a sense, thermal conductivity. Okay, as you already know, alumina is a quite good material for its properties regarding the loss tangent, as already has proved on the simulation in a sense. Okay, there's another type of material that is interesting. Let's see what happened over here. Sorry about it. Can you see the presentation? No?
Not yet.
No?
No.
Whoa. Back again.
No.
Yeah.
Good. So let me block this one in a sense. I'm lost this presentation again?
Yeah.
Why?
We see you now. Yep.
So back again, sorry about it. So then the good thing about aluminum nitride is it has, compared to alumina, it has lower density. Also, the coefficient of thermal expansion is lower. However, we have the thermal conductivity is quite interesting because with this type of material, we can reach high values like 270. However, the dispersity, as you can see in the table, okay, is quite interesting for us on the material. So we need to understand this. I don't know what is happening with my computer. Okay, so after doing some reviewing to see the difference on the properties and already shown. Okay, on developing this type of material, we have to take into account a few factors. Okay, for developing this type of material. Oh. Okay, go carry on. Sure. We have to take into account a few factors. Those factors are included, in a sense, on the composition of the material, also on the process of manufacturing. Okay, and those will be affecting the performance and also the properties of the final product. Okay, I will show a little bit more about this information, those factors. The first factor we have to take into account is the material in a sense of the crystal structure. Okay, crystal structures will be the atoms bound and how it is bound, because they will be developing some characteristics of those. Okay, so in this type of materials, aluminum nitride has many kinds of structures like cubic and Wurtzite. With those, you have a difference. Okay, with those you have a different kind of properties. Okay, there will be the intrinsic factors. The extrinsic factors will be involved in the mine. Okay, we will be involved in the raw materials, also in the synthesis process and the manufacture process. For the aluminum nitride, you have two main synthesis processes. It could be reached from alumina by carbon thermal reduction, and also it could be by direct nitridation. Okay, starting from alumina. With those two kind of ways, we have different impurities in the system, and also it could be involved in impurities on the lattice. Okay. Next one. Also, the factor on the manufacturing process that I have to take into account developing a new materials is part of the formulation that involves the composition of the materials. Also, it will involve the quantities that are used of those kind of different the raw materials and also the additives. It will impact in a little bit the process on the shaping. Wow, I'm so nervous today. It's incredible. Okay. Okay. By sintering, you need like okay. Okay, and on the manufacturing process, on developing new materials, you have to take into account so many factors. Those factors are involved in the raw materials, as also in fact impacts the process. Those process has many steps. One of the steps that I'm interested in this project, or is the evaluation on taking into account like the temperature, the pressure, and so on the for developing. Wow. I will. Okay. Yeah. Like.
Just call it. Just take your time. Okay. So no rush. Okay.
No rush. Yeah. Okay.
No, it's interesting. Yeah. So it's you only
yeah.
talk on the material. Okay.
Yeah.
So it's very interesting. Yeah. Take your time.
Thank you, Jason. Let me check it out. Okay, let me rewind. I will rewind to those factors. Okay, because those the factors for developing the material, it has many involved. Okay, the first ones are the extrinsic and extrinsic. I will start with the extrinsic that is on this slide, that involves the manufacturing process. For me, I have to start with the raw materials. Those raw materials have some impurities also. Those impurities will affect the material. Also, the process, and then the process has many stages, has already everyone told you about. For me, the main for developing the properties of the material will be on the scale of microstructure. Those microstructure has so many factors that involves so many factors that involves. Okay, that will develop the grain size and the grain boundaries. Also, the impurities will affect the microstructure. The porosity will affect the microstructure. No, it will not affect it will affect the material's properties. That's it, Elvira. That's it. Yeah, okay. Next slide, it will be better. So, in a sense, so yeah, okay. What I want you to take to from this slide is two things: that the microstructure, it will impact the materials properties. Those materials properties will be influenced by the grain size, the grain boundaries, the impurity, the secondary phases, the porosity, and the microcracks. Also, on a macro scale level, the final processing that you will do will influence the surface and roughness of the material. Also, it's important here that it will be a two main difference on how the microstructure will be developed. It will be the secondary phase. It could be on the grain boundaries, or it could be on triple points. With those two differences, you can develop different properties on the material. Okay. Now, what I want to show is how it affects one of the processings in the sintering, one of the factors that is the sintering temperature. With two types of materials, with aluminum nitride and aluminum nitride doped with yttria. Okay, we did the sintering at 3 levels of temperature, reaching difference, as you can see, relative density that impacts not much, but a little bit. Okay, it will influence the density of the material, and it will also impact the diffusivity or the thermal diffusivity of the material. The greater you get the thermal diffusivity, the greater you get the thermal conduction of the material. Okay, if you include a little bit of additive, you enhance the thermal diffusivity of the material. Okay, that's part of where's my slide? Here. Okay. So it will impact the properties. If the secondary phases were in a triple pole, the more likely will be have the different amount of reaching different properties than the ones shown here. Okay. I also did some observations on the particles on TEM. Those we found that the particles are surrounded by amorphous of compound that they have their hydroxide amorphous layer, which could react, which helps in a sense with the sintering. Okay, I don't know why. Okay, yeah. Okay, so okay. Also, the chemical factors, the amorphous layer. Good. Oh, I'm not in a flow. Okay. The influence on cell material incorporated composition of properties. Okay. Take into account this amorphous layer. We did some thermal treatments to change the chemical the chemical structure. Okay, of the secondary phases. So for wow. Okay, so the amorphous layer helps students. Okay, yeah. So okay, no, I'm quite bad today. So yeah. Okay. We also did influence on the raw materials with the different providers. With those providers, we have the different amount of oxygen content. Also, we did some measurements on the particle size. As you can see, the particle size tends to be quite around the same range. And also, after sintering, we did the thermal diffusivity. We measured the thermal diffusivity on the material. We found that the initial particle size and the oxygen content, even if it fluctuates and it doesn't impact too much on the thermal diffusivity, when we are thinking about the oxygen content on the layer that I showed in the past slide on the surface. However, oxygen content on the lattice, it will be quite different, the behavior. Okay. Okay. Changing the additives, influence in nature. Changing the additives, it will change also the properties of the material that we develop. Okay, just with aluminum nitride, with the properties or the diffusivity, we estimate by calculation the thermal conductivity of the material. So, as you can see, we reach, and our ratio also Basel, that we're reaching 60 watts MK, changing the difference. Okay. So yes. So yeah. Okay. So well, after change, yeah. So we. Yeah, carry on. So well, after developing this type of materials, we decrease a little bit of the electric loss. At some point, comparing to the theoreticals we found on the literature, is low, but as Basel showed, is not low enough. So one of the perspectives, in a sense, we have two at this point. So it will be first, develop, particles, granulation of particles of aluminum particles, because they will help in the shaping process. It will help also in the sintering stage, and also it will enhance the properties not only on the thermal, also in the dielectrical, because it will get more dense, the material, and that's one of the main factors for the electrics. Okay, you require that the dielectric properties, the loss. You require the highest density possible, the lowest porosity inside, because the porosity and also the impurities at ppm levels, the higher the frequency you go, the lowest impurities you need to have inside the crystal of the material. So that's a few things that I want you to take into account, even if I didn't explain good. Is quite a few things. Is first that for reaching the lowest loss tangent, the electric loss tangent, we require a material that is almost monophasic. Let me go back, because we require a material that the microstructure tends to be as much as possible, the secondary phases have to be the lowest amount possible. So it's quite challenging for this, in a sense. So, well, thank you for attention. Thank you for taking for